Today we will be looking at 5-6, inverse variation. So a quick review of direct variation from yesterday is that direct variation is in the form of y equals kx. The ratio of y over x is your constant, or is the k. Inverse variation then takes on the form of x times y equals k, or y equals k over x. The product of x, y is the constant. Example 1 is writing an equation giving a point. So suppose y varies inversely, which is the important part to recognize here, and I'm not sure why it's kind of going all squiggly on me, with x and y is 7 when x is 5. Write an equation for the inverse variation. So our form for inverse variation is x, y equals k. Let me try something different here. xy, well, x is 5 times y, which is 7. That means k is equal to 35. So our equation for the inverse variation then is y equals k, which is 35 over x. Remember, in an equation you always have x and y as your variable. Example number 2 then is finding the missing coordinate. The points 3, 8 and 2y are 2 points on the graph of an inverse variation. Find the missing value. Well, remember that if it varies inversely, k has to be the same for both of them. Well, in our first one, our x and y is 3 and 8. So our k, because it's inverse variation, would be 3 times 8. So our k is equal to 24. That means that in order to find y, we would use our equation y equals k over x. We know k is 24, and we know x, because it's given to us right here in our problem, is equal to 2. So our y for that coordinate would be y equals 12. Example number 3 is our problem-solving piece for this one. It says the weight needed to balance a lever varies inversely. So again, you have to just pay attention, because our next unit or our next section will mix inverse and direct up. So just pay attention to those key words. Inversely, with the distance from the fulcrum to the weight. Where should Julio, who weighs 150 pounds, set to balance the lever? Well, if we look here, we would need to have the x times y be equal to each other on each side, so that we know that the constant would be the same. Well, my x and my y here are 6 times 120. And on the other side, x, we don't know, it's right here, times 150. 6 times 120 gives me 720 is equal to 150x. The opposite of times 150 then is to divide by 150. So then we get x is equal to 4.8 feet. If we turn the page, we will get to look at example number 4. It says we want to determine if it's a direct or an inverse variation. And it says, do the data in each table represent a direct variation or an inverse variation? For each table, write an equation to model the data. So I'm going to write under here my direct variation, k, is equal to y over x. In an inverse variation, k is equal to x, y. So I'm going to use that idea to tell which one the table represents, because k has to be the same for all three of these points. Well, if I do the first one, and if I think it's direct, I would do 5 over 2. 5 over 2 gives me 2.5. Then I would do 10 over 4, also gives me 2.5. 25 over 10 also gives me 2.5. So since all of them give me the same constant when I take y divided by x, this one is a direct variation. It then wants us to write the equation. Well, in a direct variation, it's y equals kx. We found our k, the constant between each of those points, was 2.5. So it is a direct variation with the equation y equals 2.5x. Now we look at our second one. So if I want to check it for a direct variation, remember we do y over x. 20 divided by 5 is 4. On the second one, 10 divided by 10 is 1. That does not give me the same constant of variation, so it must not be direct. I need to check to see if it is an inverse variation. It's actually easier to check for because you just multiply these. 5 times 20 is 100. 10 times 10 is 100. And 25 times 4 is also 100. So because the products of the two give you the constant of variation, that means it is an inverse variation. And my equation would be y equals k over x. So my equation is y equals 100 over x. So again, to tell if it's direct or inverse, you have to see, is the quotient the same when you divide, or is the product the same when you multiply? Our last example here is example 5. It says explain whether each situation represents a direct variation or an inverse variation. And we need to talk about this in a real life scenario. For a direct variation in a real life scenario, if the input goes up, so does the output. Or you could have this scenario as one goes down, the other also goes down. An inverse variation, though, they move in opposite directions. So if one goes up, the other goes down, or if one goes down, the other one goes up. So inverse means they move in opposite directions. Direct means they move in the same direction. So if I look at this first one here, the cost of $20 worth of gasoline is split among several people. Okay, well, if we think of this as the number of people you are splitting it with goes up, what happens to the cost that you are going to pay? Well, if more people are splitting it, the amount that you pay per person would go down because you're splitting it among more people. So because as one goes up and the other one goes down, this one would be an inverse variation. Now if we look at the next one, you buy several markers for 70 cents each. Okay, well, we're talking about buying markers, so the number of markers, if the number of markers you buy goes up, what is happening to the total cost? Well, the more markers you buy, the cost also goes up. So since both of them are moving up at the same time, this one would be a direct variation. Okay, you now need to go ahead and complete the quick checks for this section and look at your schedule to find out what your assignment is for this section as well.